The idea that supplements can delay aging has moved from hopeful speculation into the realm of serious scientific inquiry, driven by a growing number of long-term, large-scale randomized controlled trials, RCTs. These studies are considered the gold standard in clinical research because they help determine not just associations, but causal effects, essential when evaluating interventions aimed at complex, multifactorial processes like aging. The significance of such trials lies in their ability to separate marketing claims from biological reality, revealing which supplements truly impact health span and biological aging and which do not. Aging is not a single disease, but rather a gradual decline in the function of multiple physiological systems, from immune resilience to mitochondrial efficiency to cellular repair mechanisms. As such, identifying compounds that can influence this trajectory requires more than short-term biomarker shifts. It demands data on real-world outcomes like reduced disease incidence, delayed onset of frailty, improved cognitive function, and extended lifespan. RCTs provide the rigorous structure needed to capture these outcomes, especially when conducted over several years and involving diverse populations. Recent trials focusing on vitamin D, omega-3 fatty acids, B-complex vitamins, and polyphenol-rich supplements, such as resveratrol and curcumin, have yielded a mix of encouraging and sobering results. For example, the VITAL study, one of the largest supplement trials to date, followed over 25,000 older adults and tested the effects of vitamin D3 and omega-3 supplements on cancer and cardiovascular disease. While the trial found modest benefits in certain subgroups, such as reduced cancer mortality in those with low baseline vitamin D, it did not confirm universal anti-aging effects. Still, such nuanced findings are essential for identifying who might truly benefit from supplementation and under what conditions. Another impactful trial, the DO Health study, examined a combination of vitamin D, omega-3s, and a simple home exercise program in older adults. The findings suggested small but measurable improvements in health outcomes like reduced infections and better bone function. Importantly, when viewed through the lens of biological aging, these modest improvements suggest that supplements can play a supportive role in slowing functional decline, especially when combined with lifestyle interventions. Telomere length, epigenetic age, and markers of inflammation are increasingly used as endpoints in these trials. They serve as proxies for biological aging, and their inclusion helps determine whether a supplement truly modifies aging pathways rather than just providing symptomatic relief. Trials using these markers have shown that vitamin D supplementation, at doses around 2,000 IU daily, may slow telomere shortening and lower systemic inflammation. Similarly, B vitamin trials have revealed reduced brain shrinkage and slowed cognitive decline in individuals with elevated homocysteine levels, again underscoring the importance of personalized baseline assessment. However, the limitations of supplement trials must also be acknowledged. Many are complicated by issues like poor adherence, underdosing, or overly heterogeneous populations. Some trials are too short to capture meaningful changes in aging, which unfolds over decades. Others fail to account for nutrient status at baseline, a critical variable, since the benefits of supplementation are often greatest in those with existing deficiencies. Without adjusting for these factors, even a beneficial intervention can appear ineffective. Yet the trend toward more sophisticated study designs is encouraging. Trials are now more likely to stratify participants by genetics, diet, and metabolic health, creating room for personalized conclusions. Advances in biological age measurement, including DNA methylation clocks and proteomic aging signatures, offer new ways to detect subtle but significant changes that were invisible to earlier generations of researchers. As this field evolves, supplements are increasingly being tested not just for their ability to prevent disease, but for their capacity to maintain function, reduce cellular damage, and extend the number of years lived in good health. In conclusion, randomized trials provide critical insights into whether supplements can truly delay aging. While no single nutrient offers a magic bullet, the evidence suggests that under the right conditions, appropriate dosing, sufficient duration, and correct population, certain supplements can indeed influence the biological processes of aging. These trials help filter hype from fact, grounding anti-aging strategies in robust clinical evidence and guiding more targeted, personalized approaches to healthy longevity.